welcome everyone. Thanks for being the brave few to attend a late session talk on Friday. I really appreciate everyone coming out here, and I'm really happy to be here. Happy to finally see everyone in person again. Feels great. Um, we're going to be talking about architecture libraries. Specifically, I am going to go through Mavericks and workflow. I wanted to actually do Decompose as well, but kind of ran out of time when preparing for this talk, and I didn't really get to spend enough time with it to give an opinion on it. So I'll save that. I'll save that for the next one. But by the way, my name is Rikin, and let's get started. So, who am I, and why am I qualified to kind of talk to you about this? Well, first and foremost, I am a snowboard enthusiast and an amateur barista by my own qualification. That just means I like making coffee and snowboarding. But in the hours in between when I'm not doing those two things, I am an Android engineer at Pinterest. I've been at Pinterest for about closing in on 4 years now, and mostly doing Android product engineering. Right now, I work in the creators org, where we're just trying to make Pinterest a better ecosystem for creators and get more creators to create more native content on the Pinterest platform. But as an Android engineer, I'm also really interested in two main areas. I like thinking about architecture and Android infrastructure, and I also like thinking about UI and making Android apps look nicer. But I'll mostly be talking about the former. Let's talk. I also just bought a house. Don't know why I'm putting that in the tech talk, but I am pretty happy about it. So we moved in about a month ago, and my wife Isha's actually here, and so we're really excited about it. So I'm learning a lot about architecture, just not the kind that I'm going to be talking to you about in this talk. And also my dog is in the first picture, but I didn't think it did it injustice since he kind of blends in. So I wanted to show my dog Sora in his natural habitat. This is actually him in the new house. He seems to be enjoying himself. So why this talk? Why am I talking about architecture? Well, Compose is out. Everyone's talking about it. I'm sure there have been countless talks talking about Compose. In fact, a talk right before Zach was talking about workflow and the workflow Compose integration. So, everyone's kind of talking about it. And because Compose is becoming the flavor, really what people want to use and adopt, I think architecture is starting to come back into flavor as well. Compose kind of has a opinionated way on how it represents state and how it expects to consume state. And so we kind of have to build our applications with that in mind. But the main reason I'm doing this talk is because I'm a little bit selfish. I really wanted to just have a reason to use these libraries, and having to do a talk about it was a good impetus for me to even try. And I think it's fun to play around with these libraries and learn things about them. So what are we going to cover? Well, we're going to go through those libraries. We're going to go through Mavericks and workflow, and we're going to go through it through a lens of an app that I built. It's like a Compose first application. And I'll basically be walking through going through maybe a feature flow, and go through that in Mavericks and go through that in workflow, and kind of show how data flows through the application and how the library is sort of helping us manage our state and kind of build a foundation for an app. And then I'll also go over some comparison criteria that I'm going to define on how I'm going to be comparing the two. And then towards the end, I'll just kind of go through my general thoughts on after using the library through my firsthand experience, how they kind of held up to those comparison criteria. And then I'll just get some last parting thoughts on in general, what do I think about them? Should you use them? When should you potentially use them for your own application? So yeah. Okay, so I mean, MVI is kind of a loaded term in my opinion. It's become very, very popular in the Android ecosystem, and it kind of has just like one Android as like the data flow / like state management representation. And what it really has become is this overarching term of like anything that uses unidirectional data flow and models state models views as a function of state. So modeling your state as like these data classes that represent what your view needs to render. And because of this, there's like multiple interpretations of this like correct architecture. And even so, you can look at the new Android architecture documentation, and they actually provide a lot of information on like, their opinions. And this is actually I think this is actually quite nice. So you should go check it out. But you'll see really quickly that it's like they go into a lot of detail, and there's a lot of thought that goes into modeling architecture for your application. So it is a hard problem, and so you kind of want to look at how people have taken their stab at solving it. So again, I'm going to be going through Mavericks. I'm going to be going through workflow. If you have any questions about workflow, Zach is in the audience, so please do not direct any questions to me because I will likely not be able to answer them for you. But there are some future explorations I'd like to work with Decompose. It seemed like a pretty similar tool to workflow. There's Molecule, Cash App, and there's Ribs. I think people still use Ribs. I know Ribs was an Uber architecture release a while ago. I don't know if people still use it, but I'll find out. So what are the comparison criteria? I chose 4 relatively broad scoped comparison criteria. I'm going to talk about like the complexity of using this library. Does it feel like I'm using Android? Is it really easy to learn, or is there a pretty high and steep learning curve to using it before you start to feel productive and comfortable? I'm going to talk about whether or not these libraries are opinionated, and what I mean by that is like, do they have strong opinions on like multiple facets of your architecture, like navigation, state management, how to represent state? Or is it just like maybe they have opinions on portions of that, but allow you to be kind of flexible on what tools and what systems you use to cover other parts of your application? And then I want to also talk about documentation, because I was coming into both of these libraries without having used them before. And so I was heavily relying on like whatever documentation already existed to learn and see if it can help me build the application that I wanted and have examples of potential use cases that I might run into. And then the last comparison criteria is testing and like test support by the library. I'm going to be honest, I didn't actually write any tests for my application using any of the tools that the libraries provided, but I did take a look at some of the test offerings that they provided. So I'll give you like a loose take on that. All right, so what I've built. I know a lot of you will be very disappointed, but I did not build a to-do list application to demonstrate all of the amazing things that these architecture libraries can do. I went a little bit against the grain, so hopefully you all can forgive me. I built a hydration, or like I built something that I personally wanted, which is just a water, personal like hydration tracker to track how much water I'm drinking throughout the day. It's a Compose first app. It's pretty simple. It's using Firebase as a backend, and it has 3 core, somewhat code-dependent features that I'll go through in a moment. And just for simplicity, I'm not going to show off like Dagger. I'm not going to add like Dagger or any modularization, just so that like we can just focus mostly on the libraries themselves. And there's one small kind kind of mini goal that I had in mind after I started using this was I wanted to see how much code we can kind of share, but like shifting between these two libraries. So we can explore that in a bit. So this is the application. I've actually posted the code on the slides, and you can take a look at it afterwards. But it's a pretty simple application. On the left, you'll see is like your daily hydration. It just kind of shows you at a glance like how much water you drank towards your goal by filling the screen with like that water indicator. You have your weekly streak screen, which kind of shows all how you've been doing this week. And then you have a settings screen, which lets you set some settings for your application, like what your goal is and what your drink size should be by default. So like you can modify that. And if you have like a water bottle that's like 16 or 32 ounces, or you want to drink more than 64 ounces in a day. Just some quick disclaimers before I get into like the meat of the talk. This won't be a Compose overview. I actually won't talk too much about like how I implemented like the Compose screens or features, just using that as like a ground for comparing the libraries. I'll be talking about them from my own personal experiences and preferences, so keep that in mind. This isn't gospel. I won't. Please don't like at me on Twitter afterwards saying that I was bashing both Workflow and Mavericks, but this is just going through the lens of my own experience. So just take what I say with a grain of salt. And I am showcasing these libraries with a relatively small application. So like a lot of you be like, okay, well, that's cool that you built a little toy app, but how am I going to take this back to my big company and utilize this? Well, the answer is you probably won't do that based on this talk, but I think that small applications serve a good purpose when you want to test out these libraries and kind of see how they might be able to scale as your application grows. And also, by using them, you can get some ideas that you can still bring back into your own companies and see if you can take some of the ideas and make them fit your own application's needs. All right, so let's talk about my own personal preferences on how I kind of model the app domain. I kind of like modeling my application with a global app state and having each feature have its own kind of embedded feature state in that application state. So a particular feature might really only be interested in like a slice of that global app state. When I model state, I typically use data classes to model view state. I feel like that's a pretty standard practice these days. And one other thing I like is I like having actions as types. So like I'll typically model the actions that go into whatever system I'm building as like an enum or seal class, depending on how complicated the actions need to be. So we'll look at these libraries and I'll try and like kind of use my own preferences and see how the libraries, if I can use them in an idiomatic way, or if I'm like really going against the grain and kind of breaking that system. This is just a quick like idea of like what the app domain for the app actually looks like. It's kind of simplified a little bit, but this is generally what it looks like. You have like that global app state, which has some properties, and then you have some of the feature states in there that will represent each of the features for its application. And then you have that sealed class, which models all of the actions that can flow into the system. So I'm going to start with Mavericks. Mavericks is a library by Airbnb, and I think mostly built and worked on by Gabriel Peel, who was at this conference as well. So feel free to talk to him if you have any more questions about Mavericks after this. The core concepts that, in my opinion, are you'll see that you'll use this Maverick state, which just notifies the system that it's meant to be used with Mavericks. You'll be using or extending Mavericks view model. That'll be your kind of primary view models that you use. And then I'll talk a little bit about how you subscribe to state within your composables from Mavericks. So Maverick state, it'll just typically just be a Kotlin data class like I showed you with the domain. Mavericks prefers that these data classes be immutable, and they actually have tooling to kind of support and force these to be immutable. Otherwise, it will throw a build failure. And these will typically implement that Mavericks state interface, which is just an empty interface. It's just used to denote that this is a state that's going to be used with Mavericks. But a big thing that that Airbnb and Mavericks really talks about is this concept of derived properties within your state, within your Kotlin data class. And actually what they are their variables assigned in the class body, so not in the class constructor. But let's dive into that a little bit, because I thought it was pretty interesting. So another way to rephrase that is that these would be calculated properties. The promise is that they would theoretically never be out of sync when you do state updates. And even Mavericks allows you to subscribe to particular properties in your state. And so ideally, you would be subscribing to some of these derived properties. And that will also let you subscribe to only the portion of the state that you are interested in. One caveat here is that if you add variables or values in the body of your data class, they won't be part of the generated like equals, hashcode functions, etc. Right? I don't think that that's too huge of a deal, but it is something to be aware of if you do depend on that for the identity for some reason. So here's an example of like how we could model a state, right, using derived properties versus just having properties in the constructor. The main difference here is that if in the first example on the top, I like want to do a state update, I have a state, and I just do like state.copy count equals whatever. Now that percent value, which was originally set to be like depend on the count and goal, it won't be recomputed. And so now you'll get into a situation where you have a property that might not necessarily be like in sync with the latest representation. And so this would be a good candidate to move it into the body as a derived property. And so now anytime I do like a .copy, update the count, update the goal, whatever, percent will be recalculated, and it'll always kind of reflect the latest value. So the other component that you will use is a Mavericks view model. This is actually really the main thing that you'll need to be concerned with. It's going to be generic on that Maverick state class that you use, and it just exposes a flow, I think a shared flow of that state. And then in order to put actions into the system, you can just have like a single function that takes the action type that I defined, or it can just be top level functions on your view model that represent your actions. And then the way that you actually do like state updates or access state, it has two core state mechanics that I'll dive into. There's set state, which will act as like the way to update state, and then there's with state, which is a way to kind of access the current state. So the main difference here, so set state is like the reducer function. This is how typically what will happen is like when you're handling your actions, you'll end up calling like a set state, which will give you a lambda that's a receiver function on the current state, and then you return a new state, and so you can just like update that state with whatever action, depending on whatever action happened, and because it's a receiver function inside that lambda, that current state is just this, so you can just call copy and update whatever fields you want on that data class. And one other thing to note is that like these reducer functions, they're actually queued on like designated coroutine dispatcher. So they won't necessarily happen synchronously. So like if I call set state and then immediately try and access that state, it might not be the updated value, which is why, which is at least I think why we also have this with state function, which gives you a lambda that takes the current state as a parameter. And the one guarantee that you get with get state is that it actually waits until the set state queue has been fully processed. So like any set state reducer operations that need to happen, it'll make sure that all of those are done before you call this with state. So you can kind of like have a little bit of a more deterministic way of accessing state that you expect to have already been updated. So just something to keep in mind. And these also run on a designated coroutine dispatcher. So subscribing to state, there is a Mavericks Compose artifact that adds like some nice, more ergonomic ways to access the things that you'll need to actually subscribe to state. So you have this Mavericks view model, which will give you a view model scoped to the closest lifecycle owner. But if you want to kind of specify that, you can also specify whatever different lifecycle owner you want as a parameter. Or if you know that you want to just like scope something to an activity or a fragment, they also have some convenience functions that allow you to get a activity or fragment scoped view model as well. And then the way that you would access the state that your view model is emitting is you call viewModel.collectAsState, and collectAsState will just convert your state class to that state type that Compose knows and loves and expects you to have. And then what I talked about previously was that you can also call another version of this collectAsState and pass a lambda where you actually are subscribing to, it'll give you the state, but then you can subscribe to a property on that state, which is what I'll be typically using to subscribe to like the individual feature states, which I'll show. All right, so that's like a very quick bare bones overview of Mavericks. So let's just like walk through that through the lens of the application that I built, and like specifically through one feature, and see how like actions go into the system and how data changes, state updates, etc. Okay, so this would be like a component graph of like, I guess, all of the things that are going on here. You have those feature components at the bottom, and those are just like composable screens that are being rendered. They're all going to be talking, in this case, to the same activity scoped app view model. So the app view model will kind of be shared across all these features. And I'll be looking at specifically the hydration feature, which is what you see on the screenshot on the left. Yeah, so let's just quickly walk through that. So let's say I tap on that fancy looking button at the bottom right. That is basically a way to update the drink counter in this application. And so let's just like take a step-by-step approach to see what's going on here. So if you look at it, we have that global app state, right? And realistically, what I really want to update or work with is this localized feature, like the hydration state. And that hydration state is actually just dependent on some of the properties. So it's a derived property. It's a derived property in the app state, and it depends on like a particular hydration state in that list. Okay, and currently that hydration state has 0 drinks and a goal of 64, and then it has the drink amounts that we know how to increment this by. So I click on that button, right, and then the way it'll send that action to the view model via a lambda that might have been passed by the view model. The view model has a function called send, which accepts these actions, right? So when that action gets to the view model, this is kind of what's going on. There's 2 main pieces, and I'm sorry if this is hard to see. I probably should have had a better version of the code posted, but we're here now. So So there's two things, right? There's a with state block at the top and a set state block right underneath it. The with state block here is just getting the current version of the state, and then it's launching a coroutine to then talk to a repository that will eventually update Firebase with what the new drink amount should be. And then at the same time, or in another, like with the set state, it's updating our local kind of in-memory version of our application state model, right? And when I wrote this, I mean, one, it's kind of a naive way to do it. I kind of just wanted a way to simultaneously just like update the data store in the backend and also just update our local state so that we can have things reflect immediately. But one of the things that I realized is that if we use, even with this approach, if we wanted to use this approach, a little bit more of an idiomatic way would be to actually call the set state before calling the with state. And if I do that, then, and it's a little bit cut off here, but then I only have to do the calculations once in that set state function. And then because of the guarantees that I get by using with state to access it after all the set state reducers have been applied, then I don't have to do those calculations again when I'm updating, Firebase or the drink repository. I can just have some guarantee that the state that I'm accessing now is the updated version of the state after that set state reducer happened. And then it's pretty simple. The app view model will then update the state, and it will emit. Well, one, it'll update the state in that global app state, and because the state is updated as a property of that global app state, the derived property for the hydration state also gets updated because it kind of depends on that. And then the feature is subscribed to particularly the hydration state in that global domain. So it'll get an emission for a new state, it gets updated, and then you see the drinks update on the screen. Pretty straightforward. One cool side effect of like modeling state in this way is that if I have codependent features, for example, the streak screen, streaks also depends on that list of hydrations that was updated from that action. So when I navigate over to that streaks feature, it'll also get recalculated once the state updates. So it kind of reacts to other features modifying state that your feature might depend on. And it's kind of cool because it just updates automatically, and I don't have to kind of juggle like all these codependencies between my features. I can just have some guarantees that it's going to get updated whenever any of the properties it depends on gets updated. So that's kind of nice. All right. So that's it for Mavericks. Let's move on to workflow. All right. So what is workflow? Well, hopefully you attended the talk right before mine, but if you didn't, it is, well, first of all, shame on you. But second of all, it's a Square library by Ray Ryan and Zach Klippenstein. And the way that the documentation kind of like describes it is this tree of composable state machines, which is pretty cool. And I'll go over again the core concept, which are, in my opinion, what a workflow is, and then what workflow actions are. Some of the view stuff, so like the things that kind of like help bind the data produced by workflows to your views, and then workers, which are kind of a cool way to handle like side effects, like reaching out into like that drink repository and pulling out the latest state and plugging it back into the system. So like I said, it's a state machine. Workflows are going to be like the core concept that you need to understand if you want to use this library. And it's generic on 4 types. It's going to have props, state, output, and rendering, and I'll go over those in a little bit more detail in a second. Workflows also have this render method, which is kind of like the key. It will render a rendering type which is the thing that will be consumed by your views or whatever wants to consume it. And then another thing to kind of understand is that workflows also sort of become your navigation graph as well. This is actually a little bit hard to grasp at first, like coming from the traditional model, and it still is a little bit confusing. I'll be honest, but I'm still working with it. But yeah, it's just something to know that workflows will also be kind of in charge of handling navigations, just by the nature of how it works. So I'm going to cover those types kind of in pairs, right? So like there was the state and rendering types that two of the types that workflows are generic on, and renderings are kind of the most important thing to understand, and they're like the view state or the view model, whatever you want to call it. But they're what your views are going to consume, and they're going to have all the data that views need to render. And the difference between that and the state is a state is like the internal state for your workflow. It is, I guess, like generally when I was using it, a lot of times like the state and the rendering ended up being pretty similar. In fact, like in a lot of use cases, I would typically just wrap my state in the rendering, and then just emit that. And then like the only extra things I might add are renderings can kind of have Lambda functions that will forward actions back into workflow so that you can handle the state updates. The one thing, I guess like the one time this kind of changed was when you start working with parent workflows and your internal state starts to become more of like your navigation graph, and then it delegates to your child workflows to determine what we're going to render onto the screen. So then the other two types that kind of also go in a pair are props and output. And so the way I would describe this is props are, well, they're data from the parent. So like I said, you can have a situation where you have a parent workflow that talks to a child workflow and vice versa. And so props are a way for that parent to give that child workflow some initial state if it's dependent on it. And then subsequently, there is an output type, which is data that you would feed back from that child workflow to the parent. And I actually really like this. Well, based on like the way that I model my domain, I kind of have this idea of sub features in my global domain. So I constantly have this idea of like mapping global state to local state and local state back into global state. And I feel like props and output just kind of work really well with that school of thought. So like props can be like, you can think about it as like, the way I would do it is I initialize my child workflow and I pluck out that local state from that global state and pass it down as props. And then similarly, when I want those state updates to propagate back to the global state, I can have that child workflow emit output, and that output can then be consumed by the parent and update the global state. And then really quickly, workflow actions, they're actually very similar to like the set state function in Mavericks. They're just state reducers. They have access to the current state. So you'll typically use these, you'll respond to like events, usually like user actions, and then you'll set up a workflow action to update the state. And then once that state is updated, it'll actually cause the workflow to call its render function with the updated state. And then you can emit a new rendering. So this is a diagram that I stole from the workflow documentation, but it very nicely kind of like shows like how the system works. So like you have that block, which is like your workflow, its internal state, and then you see props that flow from top down, and then you have output that flows back up into the system, and then you have your renderings, which are the things that your views will consume, and those renderings will also be helpful in propagating events. So let's talk about the view layer. The view layer, there's a few things that you should know, especially in the Compose world. And Zach talked about a lot of these things, but I'll quickly go over them. Yeah, so you typically will need view factories, and those view factories will kind of map your rendering to the actual view, or composable in this case. To help out with that, there's actually a Compose view factory, which will allow you to really easily create like a binding for your rendering to a composable. And an even easier way that I found out recently was actually to leverage that compose rendering type. So like now you can even define your rendering as a compose rendering, and then just inline like the composable that will be rendered, which is pretty cool. And then the way that you bridge this into like what you'll actually render onto the screen is you'll use this workflow rendering to help kind of like talk to your workflow and wire it up to whatever view factory it needs, and then display the view. So you can just use that, and it will receive the renderings, and then it'll also use the view environment, which is just a way to kind of register. Well, one of the functions is you can register your view factories to this view environment that gets passed down the tree. So it's useful to help pluck out the view factories you need for a particular rendering. And then I talked a little bit about workers. This is kind of like the opinionated way on how to like talk to the outside world and feed that data back into the system. It's essentially just a wrapper around Kotlin coroutine flows, and it will emit some output type that you can define, again, that you can feed back into the system. So I think it's actually really a really cool way to kind of like have an opinionated way to define side effects. So this is an example of something that like I would use for when I'm initializing the app state. I might talk to that repository and wrap everything in a worker, and then grab the drink for the day in a repository and help that initialize my app state, and then I might emit that. So this will be a worker that like initializes the initial app state. Okay, so we'll go through a similar walkthrough through a feature, but with workflow instead of Mavericks. So these are the components that are now kind of involved with that same feature flow. And I know there are it looks like there's like a lot more involved here, but there's a key benefit into how this is broken up now, which is there's now, instead of having the app view model talk directly to all three of the composables, I now have these child workflows, the hydration workflow, streaks, and settings workflow that all will talk to that parent workflow, but can work on the local domain of that feature instead of having to also know about the global domain. And I'll show you how that works. Okay, so again, I click that button. I used a rendering that is used for this composable to forward any actions to the workflow. And so like I said, like in this case, the rendering is really just a wrapper around like the state that I set for that workflow. And then it has like some action lambda. So in here, I'm just using that to handle click actions for this button. And then the key difference here between Mavericks and workflow is that now the hydration workflow, it doesn't really need to know anything about that global domain. And you can see that like it's a little bit easier to reason about. Instead of like updating the app state here, I'm just updating the hydration state. And all I need to do is say like, oh, I just added the drink amount to the drink, and then this is the new state. And then if I want to communicate that back to the app workflow so that I can update the global state and anything that depends on that, then I can actually pass that to the app workflow by an output. And then similarly, the app workflow can then handle that output and then run its own action to update its global state. So I think that this is a really, really cool way to kind of model it, and it allows you to kind of really only focus on a very localized domain of a particular feature, and while still allowing you to pass data back up the tree as needed. So again, After I click that button, update the state, a new rendering is emitted. It has the new data from the new state. Oop, that's my timer, so I am at time, but I'm going to see if I can keep going for a little bit. So we emit that rendering, and the composable will then take that rendering and re-render, and you see that the screen is updated. All right, I'll try and get through these really quickly since I know I'm already over time. But so these were the comparison criteria, right? I want to talk about complexity. I want to talk about how opinionated they are, testing, question, and documentation. So Mavericks, I would say, from a complexity standpoint, it's very easy to use, especially if you're already using Jetpack architecture components, Jetpack view models. The way I would describe it is like it's kind of like an ergonomic addition to all of those. So it just makes some of the state management things a lot easier. And I would say that it's somewhat opinionated in how you set up state, for example. But otherwise, it doesn't really care how you set up the rest of your app. It's just like you can set up the view model. It'll be your state management system. It'll emit state, and it can handle actions. And then whatever you want to do for like navigation or whatever, that's up to you. It's really well documented. Their doc site basically had everything I needed to kind of get bootstrapped and up and running. And it even has like compose sections for the compose integrations. And then as far as testing goes, like if you set up your app in this way, testing kind of becomes easier in general. But they did add some nice like JUnit test rules to update like test dispatchers or whatever, so that like view models operate in a better way for a test environment. So workflow. So I would say that like initially workflow was very difficult to use. It was kind of hard. It's a like hard left turn from what typical Android development looks like. But once you kind of like get started and get into it, I think it's a very cool way to model your application. That being said, it's very opinionated on basically how you model your entire application top down. It's like the Marie Kondo of app architecture, kind of like everything has a place. Everything has a place. It's really like you end up with a really well organized code base, and I think that it really shows how much thought went into the library. It's very well documented, but one of the gripes I had, and sorry Zach, but and Ray, but a lot of the times I really had to like source dive and go through the samples to really find like the solution to the questions that I have. And I feel like some of those things should have been in like the top level documentation. And especially like, I think one thing that would help is like, there's a mental model shift on how we do navigation with workflow. And I feel like there's just like not a lot of documentation on like thinking about navigation with workflow. And that's kind of like, I kind of had to learn and like struggle with that and learn as I use it. And I think that would be very helpful. But one other benefit with workflow is that they have extensive testing support. I don't have anything to show for it, but like if you actually go through their tutorials, there's one specifically about testing and all the various ways you can test your workflows. It's really cool. So the takeaways. Should you use them? Maybe. The answer is maybe. I mean, that's always the answer, but I think Mavericks might be easier to use and get started. Oh, sorry. I'm not. I won't go through the rest of these. You can look at the slides. I'm kind of at time, but let's see. Go. So here are the resources. There's the Mavericks GitHub and Docs, Workflow GitHub and Docs. The app that I built is on GitHub. I just want to thank the library maintainers, some of who are here right now. And I'd like to thank my wife, Isha, for sitting through a presentation not knowing anything about Android development. So thanks.